In today's class, we are going to find the complementary function. Okay, so at the beginning, we are going to see the rules for finding the complementary function. So you have three cases for finding the complementary function. Okay, so when you will have an equation. It can be a quadratic equation, it can be a cubic equation. You can also have higher powers of equation. Okay, so on solving this equation, you will get roots for that equation. So based on those roots only, you will have three cases. Okay, case one, the roots which you're getting, right? If all the roots are real numbers, okay, roots are real, but they need not be same, right? If they are different, so roots should be real numbers, but they can be different. Okay, for example, on solving the quadratic equation, suppose your roots are, so I'm naming the roots as m1 m2. Okay, so suppose the roots m1 is 2, m2 is 3, m3 is 4. So you can see all are real numbers, but they are different numbers. So when solving an equation, a quadratic equation or a cubic equation or a higher power equation, if suppose you get roots which are real and are different, means how do you write the complementary function is, you will write it as, here in this case we have three roots, m1, m2, m3. So you will have a constant, I name the constant as c1, e power m1x. Okay, for the first root. For the second root, it will be c2 e power m2x. Okay, so this is for root 1, root 2. For the third root, it will be C3 e power m3x. Okay, suppose you have 5 roots, this will continue. Here you have C1, C2, C3, etc. Right? These C1, C2, C3 are nothing but they are just constants. You can name it as A, B, and C also. Okay, so this is a case when you get roots which are real but they are different. This is how you write the complementary function. Okay, next case 2. Roots are again real but they are same. Okay, so what do I mean to say? Suppose again you're having roots, you have solving a cubic equation, you're having m1, m2, m3, means suppose the first root is 2, your second root is also 2, third root is also 2, means how do you write the complementary function? Okay, so how do you write this? You will write the complementary function is equal to, you have one root repeated, two root repeated, third root repeated. So for one root repeated, it will be the constant. For the second root repeated, it will be a constant into x. For the third root, it will be a constant into x square. If you have another number, means it will be constant into x cube. The powers of x will increase. Okay, so whole thing into, after you write the constant, you should have an exponential. Okay, so exponential to the power, you will have mx. Okay, this m, you can see that m1 is equal to m2 is equal to m3. So for all the things, you can use one notation. You can write e power m1x. Okay, so this is case 2, where you have roots are real but they are same. Okay, now coming to case 3. Case 3 is nothing but roots are imaginary. Okay, so imaginary means when you are finding a root, you will have complex numbers in it. Okay, so generally, how do we denote this is root is alpha plus or minus I beta. Okay, so this is the real part and this is the imaginary part that comes with an I. Okay, so whenever you're having a complex root, it will be a pair of complex root. Okay, so here you had 2, 3, 4 separately, right? But here it will be a pair. Okay, so in this case, how do you write the complementary function is, it is e raised to the real part. So e power alpha x. Okay, the real part will come outside with the exponential. Inside, how do you write is, you'll have c1 cos beta x. So you can see alpha is the real part, beta is the imaginary part. Okay, so this beta will come inside with the constant also as a cos function. Likewise, c2 sine beta x. Okay, so these are the three cases. So the last case, the roots are imaginary. So what you have to remember here is, whenever you're having an imaginary root, it will be a pair of imaginary root. Okay, so the real part will come outside and the imaginary part will be written along with the constant as a cos and a sine function.